This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The last question you might be asked to do at tangents is to find the length of a tangent to a circle from a point outside of the circle. So for example, this question here states that the circle x squared plus y squared plus 2x minus 4y plus 1 equals 0 has a tangent from the point Q at 3, 0 outside the circle which intersects the circle at the point P, and we're asked to find the length of the tangent P to Q. So we can see a picture of this situation here. So in order to find the length of PQ, what we must realize is that the triangle that these 3 points make, so our center point, the point Q, and the point P, well, we know that the line PQ is a tangent to our circle, and we know that the line from P to our center will always be at right angles to our tangent. So what we actually have here is a right angled triangle between P, Q, and our center point. So this triangle here is actually a right angled triangle. So if we can work out the lengths of these two sides, we can use our Pythagoras' theorem to work out the length of P to Q. So to do that, first we're going to need our center point and our radius length. So the center point here of our circle will be given by looking at our equation for our circle. So the number in front of x is a 2, so that means g is going to be minus 1. The number in front of our y is a minus 4, so our f is going to be 2. So we have our center point is the point 1, 2. Minus 1, 2. So then our radius is just given by that formula, square root of g squared plus f squared minus c. So when we fill in the values that we have for g, f, and c, we get our radius is square root of 4, or length 2. So that is actually the length of this red line here from P to our center. So the length of that line is square root 2. Then, and we also worked out that our center point is minus 1, 2. So what we can use now is to work out the length of this purple line here from our center to Q. We can just use our distance formula, square root y2 minus y1 plus x2 minus x1 squared. So using this formula with our 2 points, minus 1, 2 and 3, 0, we eventually work out that our distance from minus 1, 2 to 3, 0 is square root 20, so this distance is square root 20. So now what we have up above is a right angled triangle where we know the lengths of two of the side, so we can use Pythagoras' theorem to find the length PQ, which is this blue length over here. So just redrawing that triangle from above, we have a right angled triangle where we have the point Q out here, P here, and our center minus 1, 2. So we know this is a point 3, 0. But more importantly, we know that this is square root 20. And we worked out that the distance from the center to our point P is our radius, which is 2. So then all we need to do is fill in our Pythagoras' theorem. H squared is equal to O squared plus A squared. In this case, if our right angle is here, that means our H is square root 20. That's our H. And if our angle is, say, here, call it theta, then our opposite is PQ, the side we don't know, so PQ squared. And our adjacent is our R, which is 2 squared. So working out the various parts of this formula, square root 20 squared is just 20, 2 squared is 4, subtracting 4 from both sides gives you 16 rather, is equal to the length of PQ squared. So taking the square root, the length, PQ squared, and then taking the square root cancel, so we just have the length of PQ, and square root of 16 is 4. So what we eventually have found is that the length of PQ is 4. And that's our answer.